In the quietude of an October night, when most of the world had surrendered to slumber, a message traversed the digital constellation that connects our planet's observatories. The transmission, marked with 5 simple words, "Official 3i Atlas imaging data," rippled through the scientific community like the gentlest of cosmic waves. Those who received it couldn't have known that within moments, their understanding of our place among the stars would begin to shift. Not dramatically as in some grand revelation, but subtly, the way starlight bends around a distant world, barely perceptible yet undeniably real. The timestamp read 0237 UTC, a moment now preserved in the amber of human discovery, though few beyond those observatory walls would recognize its significance for many months to come. As the first frames loaded on monitors, bathed in the soft blue glow of screen light, a silence descended, not the absence of sound, but rather the presence of something deeper, a collective pause in the breath of human inquiry. The object captured in those images didn't simply look unusual. It possessed a quality that the most rational minds present struggled to articulate. Perhaps aware was the closest approximation, though even that word felt insufficient against the void of traditional scientific language. How does one describe the indescribable? How does one classify that which exists beyond our taxonomies? The astronomers present found themselves in that rare space where science touches mystery, where the known universe whispers of something just beyond our comprehension. The images themselves were unlike anything catalogued before, not in their composition, pixels arranged to reveal distant light, but in what they revealed about 3i Atlas itself. The interstellar visitor had returned to our neighborhood of stars, quietly passing through the outer reaches of our solar system like a phantom ship drifting through cosmic fog. Its surface caught the distant sunlight in ways that defied conventional reflection patterns, sometimes absorbing light completely, other times reflecting it in narrow, focused beams that seemed to pulse with an internal rhythm no natural object should possess. Time, in those early moments of revelation, seemed to stretch and compress simultaneously, a phenomenon not unlike the object itself, which appeared to exist between definitions, between the categories we so carefully construct to make sense of our universe. Was it a comet, an asteroid, or something our language had not yet evolved to name? These questions hung in the air of observatories from Mauna Kea to the Atacama Desert, from the radio telescopes of Puerto Rico to the optical arrays of South Africa, all now united in their collective contemplation of something that shouldn't be, yet undeniably was. The story of 3i Atlas began long before this moment, of course, as all cosmic tales do. First discovered in 2019, it had initially appeared to be just another interstellar vagabond, one of countless objects ejected from distant star systems to wander the void between solar families. It entered our system quietly, a brief flicker on our astronomical radar, before seemingly departing with the same indifference with which it had arrived. Scientists catalogued it, studied it briefly, and ultimately filed it away among the growing library of interstellar objects that occasionally pass through our cosmic neighborhood. Yet something about this particular visitor had always felt unresolved, like a musical note that never quite reaches its resolution. Certain spectral readings had suggested behaviors inconsistent with known natural processes, subtle anomalies that were easy to dismiss as measurement errors or instrument aberrations. After all, the simplest explanation is often the correct one, and what could be simpler than assuming an interstellar object behaves according to the laws of physics as we understand them? And so 3i Atlas faded from scientific attention, if not entirely from memory, its mysteries left unexplored as our telescopes turned to newer, brighter objects of interest. But now, with these new images arriving like whispers from the dark, the question arose, had 3i Atlas ever truly left? Or had it merely drifted beyond our ability to observe, patiently moving through the darkness until technology advanced enough to bring it back into our awareness? The reappearance of its signal suggested something even more unusual. Perhaps it had changed course, adjusted its trajectory in ways that natural objects, bound by gravity and momentum, simply should not. This possibility hung in the air unspoken, too extraordinary to voice but impossible to ignore completely. As dawn approached on that October morning, the first light of our nearest star gradually overpowered the distant points of light that had kept the night astronomers company. Yet the images of 3i Atlas remained on their screens, a digital echo of something passing through our cosmic neighborhood, neither announcing its presence nor concealing it. It simply was, existing in a state of perfect ambivalence to our observation, our curiosity, our need to classify and understand. And perhaps that was the most unsettling quality of all, its complete indifference to being seen. The newly released images were the result of a collaboration more extensive than the public would initially be told. NASA, the European Southern Observatory, and several independent astronomers had joined resources and expertise, utilizing technologies that pushed the boundaries of what was thought possible in deep space observation. Deep field imaging captured details that should have been lost to the darkness at such vast distances. Multi-spectrum filters revealed aspects of the object that remained invisible to conventional observation techniques. Together, these methods painted a portrait of something extraordinary, not merely in its origin beyond our solar system, but in its very nature. The surface texture of 3i Atlas defied easy categorization. It appeared metallic in some frames, reflecting light with an efficiency that suggested polished material, rather than the rough, porous surface of a typical comet or asteroid. Yet this metallic quality was inconsistent, interrupted by patterns that resembled fractures or fissures, not random as one would expect from natural collision events, but organized in ways that suggested purpose, design. Most puzzling were the sections that resembled glass that had somehow healed itself, smooth surfaces interrupted by lines that appeared to have once been breaks, but had since been repaired, as if the object possessed some form of self-healing capability. Even more confounding were the frames showing faint pulsations of light along the edge of the object. These were not reflections of solar radiation, their rhythm too precise, too consistent for simple reflection. The light seemed to emanate from within 3i Atlas itself, a gentle glow that brightened and dimmed according to patterns that, when analyzed, revealed mathematical consistencies that made some of the astronomers shift uncomfortably in their seats. Natural phenomena can indeed create regular patterns, but these pulsations followed sequences that seemed almost deliberately encoded, like a message written in the language of light and darkness, transmitted across the void without concern for whether anyone was listening. The photometric analysis of these light patterns revealed what some would later call the impossible signature, repeating bursts of illumination that maintained their structure and rhythm despite the object's movement through space. Scientists, always cautious in their public statements, insisted that this could still be a natural reflection pattern, perhaps the result of an unusual surface composition interacting with radiation in ways we hadn't previously observed. The universe, after all, is vast and strange, and our understanding of it remains limited by our imagination and the reach of our instruments. But privately, in secure communications and late-night discussions that wouldn't be revealed until months later, other possibilities were considered. The light flickers followed mathematical sequences that bore uncomfortable resemblance to prime number intervals, those indivisible numbers that some have suggested might serve as a universal language, recognizable to any intelligence capable of mathematics. This pattern was subtle enough to be dismissed as coincidence, yet consistent enough to raise questions about whether the cosmos itself might be trying to communicate through this wandering messenger, or whether something else entirely was at work. As the images were analyzed, catalogued and cautiously shared among scientific institutions, a sense of both wonder and unease permeated these exchanges. The traditional boundaries between astronomical disciplines began to blur. Cosmologists consulted with mathematicians, who in turn sought input from specialists in signal processing, and even, in a few notable instances, experts in cryptography. What began as routine astronomical observation had evolved into something that felt more like translation, an attempt to understand a message no one was entirely certain existed in the first place. Beyond the academic institutions, in the quieter corners of independent research, even more unusual theories took root. Some suggested that 3i Atlas might be more than a passive object drifting through space, that it might possess some form of agency, purpose, even consciousness. Such ideas remained firmly outside mainstream scientific discourse, of course, relegated to speculative papers and discussions that carefully avoided making claims that couldn't be substantiated by evidence. Yet the seed of these thoughts had been planted, taking root in the fertile soil of human imagination. Days after the initial images surfaced, the situation grew more complex. A faint radio pulse was detected near the coordinates where 3I Atlas had been observed. Unlike the visual data, which could at least theoretically be explained through natural phenomena, this radio signal possessed characteristics that pushed the boundaries of conventional explanation even further. It lasted only 19 seconds, a brief whisper, against the background noise of the universe, but within that short duration was contained a signature, unseen in natural emissions. Most in the scientific community initially dismissed this signal as cosmic interference, perhaps radiation from a distant pulsar or the echo of some other astronomical event coincidentally aligned with 3I Atlas's position. Such coincidences, while unlikely, are not impossible in a universe as vast and active as ours. Yet this explanation became harder to maintain when several observatories, operating independently and using different equipment, recorded identical frequency patterns from the same coordinates. The signal, whatever its source, was real, and it was specifically associated with the interstellar object that had already defied expectations. In the silence of space, even a 19-second whisper can carry profound implications. Radio waves don't naturally organize themselves into coherent patterns with internal consistency unless directed by some process, either a natural mechanism we don't yet understand or something else entirely. The signal contained no clear message in any human language, no mathematical formula that could be immediately recognized, no binary code that translated into images or instructions. Instead, it seemed to exist in a space between noise and information, suggesting structure without revealing meaning, much like 3I Atlas itself. The response within the scientific community was measured, cautious exactly as one would expect from those trained to value evidence and repeatability above all else. Public statements emphasized the likely natural explanations while acknowledging that further study was needed. Grant proposals were hastily prepared to secure additional observation time on the world's most powerful telescopes. Research teams were assembled to analyze the existing data from every possible angle, searching for the key that would unlock this cosmic puzzle. Yet within a week of these developments, something unexpected occurred that would cast a shadow of doubt over the transparency of the entire process. Several data archives temporarily went offline, not all at once, which might have suggested a coordinated action, but in a staggered pattern that almost seemed designed to avoid attention. Access logs revealed multiple redactions, labeled with the cryptic phrase "classification pending," a bureaucratic term that neither confirmed nor denied the implications of censorship, but certainly suggested that someone, somewhere, had deemed some aspect of this information too sensitive for open scientific discourse. Independent researchers who had been downloading and analyzing the raw image data reported that certain frames had been replaced with blurred placeholders or simply removed entirely. The official explanation cited routine maintenance, data corruption, or calibration errors, all plausible reasons in isolation, but suspicious in their sudden collective occurrence. Whether this represented simple administrative caution, technical difficulties, or something more deliberate remained unclear. But the missing data left behind an echo of digital unease, a sense that perhaps the full story of 3I Atlas was not being shared with the scientific community, let alone the public. This atmosphere of uncertainty and partial disclosure created precisely the conditions where speculation could flourish. In the absence of complete information, human minds naturally fill the gaps with narratives that make sense of the fragments they can see. And so theories multiplied like stars in a clear night sky, some rooted firmly in scientific principles, others venturing into territories that mainstream astronomers would hesitate to explore. The line between careful analysis and imaginative interpretation grew increasingly thin. It was against this backdrop that two scientists broke ranks with the institutional silence, one from Japan's National Astronomical Observatory and one from Chile's ALMA facility, chose to speak anonymously to a respected science journalist about their direct observations of 3I Atlas. Their decision to circumvent official channels was extraordinary, a breach of protocol that risked professional consequences. Yet they felt compelled by what they described as an ethical obligation to transparent science. These astronomers described surface formations on 3I Atlas resembling geometric fissures, regular patterns that suggested intelligent design rather than natural processes. More striking were their accounts of areas that appeared to self-emit light, regions on the object that glowed not from reflected sunlight, but from some internal energy source. Such claims, if made publicly under their names, would have been career-ending without irrefutable evidence. Perhaps that explains why their respective institutions quickly moved to discredit their statements, suggesting that the anonymous sources had misinterpreted data or were not, in fact, affiliated with the research teams as claimed. Yet neither scientist retracted their words, even as pressure mounted. One final message, sent before their communication channels fell silent, contained words that would later be quoted in hushed conversations at astronomical conferences around the world. "It's not just passing by, it's watching." Whether this represented a literal observation or a poetic interpretation of the data remains uncertain. The scientists themselves became as elusive as the object they had studied, declining further interviews and eventually returning to their regular research duties as if nothing unusual had occurred. As more sophisticated analysis tools were brought to bear on the existing images, another aspect of 3I Atlas emerged that defied conventional explanation. Advanced reconstruction software, designed to model the three-dimensional structure and movement of astronomical objects from two-dimensional images, revealed rotation patterns unlike anything observed in natural bodies. Where asteroids and comets typically rotate along predictable axes determined by their mass distribution and the forces acting upon them, this object appeared to drift, then stop, then change its orientation as if choosing when and how to turn, a behavior no passive rock drifting through space should possess. Its shape, too, raised questions. Initially assumed to be roughly elongated like many asteroids, more detailed analysis suggested a curved structure with internal voids that seemed to resonate under specific frequencies of electromagnetic radiation. Some researchers compared its motion to that of a vessel adjusting course, though such comparisons were carefully framed as analogies rather than literal descriptions. The movement patterns, when tracked across multiple observations, showed deviations from the trajectory that gravity alone would dictate, small adjustments that, while individually insignificant, collectively painted a picture of an object not entirely subject to the passive forces of nature. These observations created a profound tension within the scientific community. The foundations of modern astronomy rest upon the assumption that objects in space follow the laws of physics as we understand them. They move according to gravity, momentum, and the other forces we have catalogued and quantified. When an object appears to behave outside these parameters, the first assumption is always that our measurements are flawed or our understanding incomplete, not that the object itself is defying natural law. And yet, as the evidence accumulated, the uncomfortable possibility that we were witnessing something truly unprecedented became increasingly difficult to dismiss. The division within scientific circles deepened. Some insisted that 3I Atlas was simply a comet fragment shaped by billions of years of interstellar collisions and radiation exposure, its unusual properties the result of physical processes we hadn't yet fully documented. Others began quietly exploring theoretical models that allowed for non-natural origin, careful to frame such exploration as purely hypothetical, an exercise in examining all possibilities rather than a claim about reality. Between these extremes lay the uncomfortable truth that the data didn't fit neatly anywhere in our existing frameworks of understanding. This ambiguity created a unique moment in the philosophy of science. How do we proceed when confronted with observations that resist classification within our established categories? At what point does the accumulation of anomalies justify considering explanations that lie outside conventional scientific paradigms? The line between cosmic accident and cosmic intent, between a universe governed solely by physical law and one that might contain other forms of agency, grew thinner. With every new observation of 3I Atlas, while this intellectual wrestling match continued behind the Closed doors of research institutions. Something unexpected happened. The images leaked online. No one claimed responsibility for the breach, and investigations into its source proved inconclusive. But once released, these images spread rapidly across digital networks, and public fascination with 3I Atlas exploded like a supernova, releasing energy that had perhaps been building in the collective human consciousness, a readiness to contemplate our place in a universe that might contain other intelligences. Forums filled with speculation, ranging from the scientifically informed to the wildly imaginative. Documentaries emerged overnight, cobbling together expert interviews, visualization of the limited data available, and plenty of conjecture to fill the substantial gaps in public knowledge. Countless amateur astronomers turned their modest telescopes skyward, hoping to glimpse this cosmic visitor themselves, though it remained far beyond the reach of all but the most powerful observational equipment on the planet. Governments, predictably, released statements designed to reassure. 3I Atlas posed no threat, they insisted. It was a natural phenomenon being studied through normal scientific channels. There was no evidence of alien technology or intelligence, a curious denial, some noted, of a claim that had not been officially made. These reassurances, delivered with carefully calibrated casualness, seemed designed to diffuse public excitement rather than engage with the genuine questions being raised. And the silence that followed these statements felt heavier than any alarm, a void into which imagination readily flowed. The cultural response to 3I Atlas revealed as much about humanity as the object itself. Just as light splits into a spectrum when passed through a prism, this single astronomical phenomenon refracted through human consciousness to produce a rainbow of interpretations, each colored by the fears, hopes, and preconceptions of those doing the observing. Some saw threat where others saw promise. Some found terror where others discovered wonder. The object became a mirror reflecting our own complex relationship with the unknown. As with all great mysteries throughout human history, art rushed in where science hesitated. Painters, filmmakers, musicians, and poets began depicting 3I Atlas not merely as an astronomical curiosity, but as a wandering messenger of the void, a symbol laden with meaning. Some saw beauty in its apparent loneliness, a solitary traveler between stars, perhaps the last remnant of some distant civilization or world. Others sensed warning in its calm passage through our system, a silent observer taking note of our existence before continuing on its inscrutable journey. Through these artistic interpretations, humanity began to see itself reflected in the object's quiet presence. We too exist in isolation, our solar system a tiny island in the vast cosmic ocean. We too search for meaning, sending our own messages into the void in hopes that someone might be listening. And we too live with uncertainty about our place in a universe whose full nature remains tantalizingly beyond our comprehension. In contemplating 3I Atlas, we were in many ways contemplating ourselves, our loneliness, our curiosity, our deep need to connect with something beyond our experience. Months after the initial discovery, as the initial excitement began to settle into more sustained research, a pattern emerged that added yet another layer to the mystery. Detailed analysis of the object's faint emissions revealed striking similarities to radio bursts recorded decades earlier, signals that had been catalogued but never explained, filed away as cosmic anomalies for future researchers to puzzle over. The alignment was too precise to dismiss as mere coincidence. Either these earlier signals had somehow predicted the arrival and behavior of 3I Atlas, or more unsettling, the object itself had been present, or at least influential, far longer than anyone had realized. This connection between past and present observations suggested continuity, a persistent phenomenon that had been intersecting with human awareness for generations, perhaps centuries, its significance obscured by our limited understanding and the fragmentary nature of our observations. Whether this represented some form of communication, a deliberate attempt to make contact across vast distances of space and time, remains unverified. But the pattern felt deliberate, as though 3I Atlas had been whispering from afar long before we knew its name, waiting for us to develop the capacity to truly listen. The implication of this potential longevity transformed the narrative surrounding the object. No longer was it merely a passing curiosity, a brief visitation to be observed and catalogued. Instead, it began to seem more like a presence that had been accompanying humanity's development, perhaps observing our technological evolution, our growing ability to perceive and interpret the cosmos around us. Such thoughts, while speculative, were not confined to the fringes of discourse. They appeared in peer-reviewed papers, carefully framed as hypotheses to be tested rather than conclusions to be accepted, but present nonetheless in the scientific conversation. At a mountaintop observatory in Chile, where the air is thin and the stars shine with remarkable clarity, a team of astronomers captured what would become the clearest image yet of 3I Atlas. The southern hemisphere location offered unique advantages for observing the object's current position, and state-of-the-art adaptive optics compensated for atmospheric distortion to reveal details previously hidden from view. As the image processed, pixel by pixel assembling on the high-resolution display, the team fell into the same profound silence that had marked the initial discovery months before. The image revealed an almost human-like symmetry within the object's structure, not in the sense that it resembled a human form, but rather that it displayed the kind of deliberate balance and proportion that we associate with conscious design, rather than random natural processes. Most striking were two parallel grooves, evenly spaced, that ran along what appeared to be the main axis of the object. These grooves glowed faintly with a light that, according to the instruments, had no external source. It was as if the object contained its own inner luminescence, concentrated in these carefully structured channels. One scientist, a veteran of decades of astronomical observation, who had documented hundreds of comets, asteroids, and distant planetary bodies, wept silently as he studied the image. Another whispered, "That's not erosion," giving voice to the thought that had formed in all their minds. Natural processes, impacts, radiation exposure, thermal stress, can indeed create patterns on the surfaces of objects in space. But they do not typically create perfect symmetry, equal spacing, or self-luminous pathways. The moment felt sacred, even if the conclusion it suggested remained unproven. A glimpse of something that might forever alter our understanding of our place in the cosmos. This revelation, like those before it, brought its own particular quality of disquiet. The closer we looked at 3I Atlas, the less sense it seemed to make within our existing frameworks of understanding. It was as if the object existed in a space between our categories, neither fully natural nor conclusively artificial, neither clearly inert nor obviously alive. This liminal quality created cognitive dissonance among even the most rational observers, a sense that reality itself might be more fluid, more open to interpretation than our scientific orthodoxy typically allows. Some researchers began reporting an unusual phenomenon that few were willing to discuss in formal settings: dreams of the object. Night after night, they found themselves encountering 3I Atlas in their sleep, not as a distant astronomical body, but as a presence somehow both vast and intimate, communicating in ways that dissolved upon waking, but left behind a residue of significance. While most dismissed these experiences as simply the result of minds preoccupied with an intellectual puzzle, others wondered whether the stillness of this interstellar visitor might somehow echo into the human subconscious, creating a form of communion beyond our current scientific understanding. This blurring of boundaries between observation and something deeper, call it communion, connection, or simply a different mode of perception, left even hardened skeptics with a sense of unease. Science operates best in realms where subject and object remain clearly delineated, where the observer stands apart from the observed, measuring and analyzing from a position of detachment. But 3I Atlas seemed to challenge this fundamental separation, inviting a form of engagement that felt more participatory than merely observational, as if the act of studying it created a relationship that transcended conventional scientific methodology. Just as the research community was struggling to integrate these experiences within their understanding, a final transmission arrived from the Space Telescope Array that would add yet another layer to the growing mystery. The array, positioned to capture the object from a unique angle, recorded something that defied immediate explanation, a mirrored reflection within the object's surface that appeared to show a faint but recognizable image of Earth, not as it might appear to the object from its current position, but rather as if captured from a much closer vantage point. perhaps from earlier in its journey through our solar system. Scientists' first response was to dismiss this as image interference, a processing artifact, or perhaps light from Earth itself somehow contaminating the telescope's sensitive instruments. Yet detailed analysis of the raw data told a different story. The reflection appeared consistently across multiple frames, resistant to attempts to explain it away through known optical phenomena or equipment malfunction. Whether this represented an actual reflective capability, a surface so perfectly polished that it could capture and preserve images across vast distances, or something even more inexplicable, remained uncertain. This apparent reflection of our own planet within the surface of an interstellar visitor created a strange recursive loop in the ongoing narrative. We had been observing 3I Atlas, cataloguing its properties, debating its nature, and now it seemed that perhaps it had been observing us in return, carrying our image within itself like a memory or a message. The coincidence, if indeed it was mere coincidence, of Earth appearing within the object's gaze raised questions about intentionality and purpose that straddled the boundary between scientific inquiry and philosophical reflection. As the evidence accumulated and the mystery deepened, a more fundamental question began to emerge in discussions among scientists, philosophers, and the growing community of individuals fascinated by 3I Atlas. If we accept, even hypothetically, the possibility that this object might be artificial, the product of intelligence and purpose, rather than merely natural forces, then what might that purpose be? The absence of aggressive action didn't necessarily imply the absence of intent. Something could be watching without threatening, observing without intervening, present without announcing its presence. Perhaps, some suggested, 3I Atlas represented a relic, a remnant of some ancient technology, still functioning long after its creators had vanished from the cosmic stage. This would explain its apparent purposefulness without requiring the ongoing presence of a controlling intelligence. Like the space probes humanity has sent to the outer planets, it might continue its mission automatically, gathering data and making adjustments according to pre-programmed parameters, a ghost ship sailing the cosmic ocean with no living hand at the helm. Others proposed more active hypotheses. One unverified note, allegedly from a researcher who had been working directly with the radio signal data, suggested that the object might be listening specifically for signs of consciousness itself, not merely for technology or radio transmissions, but for the patterns of thought and awareness that distinguish intelligent life from the background processes of nature. It listens for minds like ours, the note claimed, testing whether what exists here is simply chemistry or something more. Such speculation, while fascinating, remained just that: speculation, hypothesis, exploration of possibility, rather than assertion of fact. The scientific process demands evidence, repeatability, falsifiability. And yet, in confronting something potentially outside our existing paradigm, we found ourselves in a space where the usual tools of verification might be insufficient, where we might need to develop new methods of understanding appropriate to phenomena that don't fit neatly into our established categories of knowledge. The phenomenon of 3I Atlas ultimately forced humanity to turn a mirror upon itself. How we responded to this ambiguous visitor revealed more about our own nature than about the object we were studying. Some reacted with fear. The unknown has always triggered our deepest survival instincts, our tendency to perceive threat in anything we don't understand. Others approached with wonder and openness, seeing in this mystery an opportunity to expand our conception of what might exist in the vastness beyond our atmosphere. Between these responses, between fear and fascination, lay the true measure of our species. We had reached a point where these seemingly opposite reactions began to merge, where scientific curiosity existed alongside a quiet awe at the possibilities unfolding before us. In that stillness, in that space between knowing and not knowing, we caught a glimpse of ourselves as both insignificant motes in an inconceivably vast cosmos and conscious observers capable of contemplating that vastness, simultaneously small and infinite. As months passed and the initial wave of excitement receded, public interest inevitably began to fade. News cycles moved on to more immediate concerns, political developments, environmental changes, the day-to-day dramas of human existence. Scientists, too, were drawn to other projects, other puzzles, the countless other mysteries that the universe presents for our contemplation. Research funding, always limited, flowed toward questions with clearer pathways to resolution, problems that promised answers rather than deeper enigmas. Yet through this gradual return to normal scientific operations, the object itself continued its silent journey through the darkness, neither accelerating nor slowing, neither approaching nor retreating, simply moving according to its own inscrutable purpose. No further transmissions were detected, no additional patterns identified. It was as if, having made itself known or having been noticed despite its indifference to detection, it had returned to its primary purpose, whatever that might be. Something about its trajectory, however, continued to trouble those few astronomers who maintained their observation of 3I Atlas, even as their colleagues turned elsewhere. Its path through our solar system didn't quite match what gravity alone would dictate. The deviations were subtle, almost imperceptible, but present nonetheless in the data, small adjustments that, when plotted over time, suggested a course that wasn't random but intentional, a path that brushed against the edge of our awareness without fully engaging it, like a stranger passing close enough to acknowledge your existence with a glance, but not stopping to speak. This quality of intentional distance, of presence without full disclosure, left the mystery intact even as interest waned. 3I Atlas had entered our consciousness, but provided no resolution, no clear answers to the questions it raised by its very existence. It remained a puzzle piece that didn't quite fit into the image of the cosmos we had been assembling over centuries of scientific observation, not contradicting what we knew exactly, but suggesting that our picture remained incomplete in ways we had not anticipated. Before fading completely from telescope range, Atlas offered one final enigma, a faint red shimmer that appeared to pass across its surface like a wave, visible for only a few seconds before the object returned to its previous appearance. Some observers called this a goodbye, a final communication before the visitor passed beyond our ability to perceive it. Others, maintaining their scientific caution to the end, said it was simply a natural reflection, perhaps solar radiation interacting with the object's surface composition in ways that created a momentary optical phenomenon. But in the stillness of that moment, as the red light moved across the surface of this interstellar enigma, it felt to many who witnessed it like something more significant, as if the universe itself had blinked, briefly but purposefully, acknowledging our observation before continuing its ancient processes undisturbed. This perception, while subjective and impossible to verify through instrumentation, nonetheless left an indelible mark on those who experienced it, a sense of having brushed against something larger than human understanding, if only for the briefest of moments. Now, as the object drifts beyond the reach of our most powerful telescopes, back into the sea of stars from which it emerged, we are left to archive both the data we collected and the questions that data inspired. Scientists catalogue the observations, the spectral analyses, the movement patterns, storing them for future researchers who might bring new perspectives, new technologies, or new theoretical frameworks to bear on the mystery. Philosophers archive the questions about consciousness, purpose, and our place in a universe that might contain other forms of awareness or intelligence beyond our own. And as we close our eyes tonight, as we surrender to sleep beneath the same stars that have witnessed the entire human story from its beginning, 3I Atlas continues its journey, silent, unmeasured, and perhaps watching in ways we cannot comprehend. Whatever it was or is, natural phenomenon, ancient artifact or active presence, it leaves us with one enduring thought. Sometimes the universe whispers its secrets rather than shouting them, and sometimes in its vast and ancient silence, it simply listens to our whispers in return. In the endless, silent expanse where time loses meaning, where light travels undisturbed for eons, something moved against the current, something not from here. On that cool autumn night, October 12, 2019, as humanity slept beneath a canopy of familiar stars, a visitor arrived unannounced from the depths beyond our solar neighborhood. The sky was particularly clear that evening in Mauna Kea, the observatory dome rotating with a soft mechanical hum as astronomers prepared for another routine night of cosmic observation. The air was thin at this altitude, the stars unwavering in their ancient light. Within the control room, screens glowed with the soft blue illumination of data streams, numbers, coordinates, brightness readings, the poetry of science translating the universe into human understanding. It began as nothing more than a faint smudge, barely distinguishable from background noise. A technician might have dismissed it entirely, had the automated detection system not flagged the anomaly, an object moving at an unusual vector, its trajectory suggesting an origin far beyond our solar system's birthing grounds. Imagine that moment of discovery, fingers hovering over keyboards, breath held in the quiet chill of scientific anticipation. The soft glow of monitors illuminating focused expressions as the object's path was calculated and recalculated, each iteration confirming what seemed increasingly impossible. This was no ordinary asteroid or comet, bound to our sun's gravitational embrace. This was a traveler from another star system entirely. They designated it 3I Atlas, the third known interstellar visitor after Oumuamua and Borisov. But unlike its predecessors, this object possessed qualities that defied immediate categorization. As telescopes across the globe turned their unflinching gaze toward this cosmic wanderer, scientists noticed something unusual. Its brightness fluctuated in ways that could not be explained by tumbling rotation alone. The silvery glow seemed to pulse, not reflect, as if the object were breathing in the cold vacuum of space. Particles of interstellar dust drifted around it, catching the distant sunlight in a halo of diffuse illumination. The darkness between stars is never truly empty. It carries the microscopic remnants of stellar births and deaths, the elemental ash from which all matter eventually forms. Against this backdrop, 3I Atlas moved with purpose, its trajectory cutting across the orbital planes of our planetary neighbors with mathematical precision. In those first quiet hours of observation, before the news would spread through the scientific community, a subtle unease settled over the observatories tracking the object. It wasn't simply its unexpected arrival that caused concern, but something about its behavior, something in the way it interacted with light and space that whispered of intention rather than cosmic chance. Was this merely an ordinary rock, sculpted by the forces of nature and sent wandering through the void? Or was it something deliberately crafted, bearing the silent signature of intelligence? The question remained unspoken in those early hours, but it lingered in the space between data points, in the contemplative silence of astronomers watching their screens with growing wonder. The night sky has always been humanity's first frontier, the canvas upon which we've projected our deepest questions about existence. From ancient civilizations mapping constellations to modern scientists probing distant galaxies, we have searched the stars for answers, and perhaps for companionship in the cosmic solitude. 3I Atlas arrived like a question mark against that dark canvas, challenging our understanding of what lies between the stars. As the Earth continued its eternal rotation, bringing dawn to the observatories in Hawaii, the data was already streaming to facilities in Chile, where the night was just beginning. The handoff between observers created an unbroken chain of surveillance, ensuring that every flicker, every subtle variation in the object's behavior would be recorded and analyzed. Imagine the delicate dance of photons, traveling millions of kilometers through the vacuum, light that had touched this mysterious visitor continuing its journey until it entered our telescopes, our instruments, our consciousness. Each captured image represented a moment already past, a glimpse into history rather than the present. By the time we saw 3I Atlas, it had already moved on, continuing its silent journey through our neighborhood of space. The preliminary data suggested an object approximately 100 meters in diameter, small by cosmic standards, yet large enough to command attention. Its surface appeared unusually reflective, bouncing back sunlight with an efficiency that surpassed most known cometary bodies. But it was the rhythmic fluctuations in brightness that captured the imagination of those first observers. A pattern too regular to be dismissed as random, too persistent to be ignored. In the soft glow of control room monitors, the earliest images were enhanced, filtered, analyzed through various spectrographic techniques. The more they looked, the stranger it seemed. Unlike Oumuamua's elongated cigar shape or Borisov's familiar cometary appearance, 3I Atlas defied immediate categorization. Its silhouette seemed to change as it rotated, suggesting facets or surfaces arranged in ways that natural erosion rarely produces. As the first night of observation gave way to morning, the data packets traveled across the globe, through fiber optic networks, satellites, and server farms. Knowledge of the visitor spread among specialists first, a quiet ripple of professional communication before the wider announcement. Email notifications chimed on phones and computers around the world as astronomers awakened to the news. Something unusual had entered our solar system, and it was behaving in ways that challenged conventional explanation. The universe operates in patterns we have spent millennia trying to decode: mathematical relationships, physical laws, the elegant dance of matter and energy across time and space. Within those patterns, anomalies stand out like whispers against silence. 3i Atlas was such a whisper, barely perceptible yet impossible to unhear once detected. Its passage through our cosmic neighborhood would leave us changed, not by any direct interaction, but by the questions it forced us to ask of ourselves and our place among the stars. In those first tentative hours of discovery, before theories multiplied and debate intensified, there was simply the pure wonder of encounter, the recognition that something from beyond our solar family was passing through, carrying with it the dust and secrets of distant stars. If objects could have memory, what stories might this traveler tell of its journey through the interstellar void? What cosmic events had it witnessed in its silent passage through the galaxy? The sky had blinked at us, and for the first time in recent memory, it seemed as though something might be looking back. Within hours of the initial detection, radio telescopes around the world began reorienting their massive dishes toward the coordinates of 3i Atlas. These sentinels of science, designed to capture the faintest cosmic whispers, stood ready to listen for any signal that might emanate from the interstellar visitor. The Green Bank Observatory in West Virginia, Arecibo in Puerto Rico, the massive FAST telescope nestled in the mountains of China, all turned their sensitive receivers toward this new point of interest. Listening to the cosmos requires extraordinary patience. Radio signals traveling through the vacuum arrive as mere whispers against the thunderous background of stellar radiation, pulsars, and the omnipresent cosmic microwave background, the lingering echo of the universe's birth. Distinguishing meaningful patterns from this cosmic static demands sophisticated filtering algorithms, careful frequency isolation, and the patient attention of experienced observers. The first data streams arrived fragmented, bursts of static interrupted by strange rhythmic intervals that defied immediate explanation. In the quiet rooms where radio astronomers gathered, the initial responses were cautious, measured in the language of scientific uncertainty. Instrumental noise, some suggested, a common phenomenon when calibrations are slightly misaligned. Unverified signal, others noted in preliminary reports, unwilling to make claims that might not withstand scrutiny. Yet as the hours passed and additional observations accumulated, the patterns persisted. There was a rhythm to the interruptions, a mathematical consistency that appeared to align perfectly with the object's rotation period of approximately 11.2 hours. The coincidence was too precise to dismiss casually. If this were merely instrumental noise, why would it synchronize so perfectly with the physical behavior of a distant object? Imagine the subtle dance of radio waves traveling through space, electromagnetic ripples spreading outward from their source, diminishing in strength with distance, yet retaining their fundamental information. Like concentric circles expanding from a pebble dropped in still water, these invisible waves carried potential meaning across the void. The radio telescopes, with their massive reflective dishes, captured these faint signals and funneled them into receivers where they were converted into data streams, visual representations of invisible cosmic conversations. The observational data revealed something curious. The signal strength varied not only with the rotation of 3i Atlas, but also with its position relative to our Sun. When the object passed through certain coordinates along the ecliptic, the plane in which most planets orbit our star, the signal briefly intensified before fading again. This positional relationship suggested either a solar influence on the emissions or, more intriguingly, a purposeful orientation toward our central star. In the soft glow of computer monitors, specialists in signals analysis examined the frequency patterns with growing fascination. There was structure here, not the random distribution of natural radiation, but something that hinted at organization. Certain frequency bands contained more activity than others, with clear boundaries between signal and silence. The patterns repeated with precise timing, like a cosmic metronome keeping beat across the solar system. Something about the rhythm felt intentional, as if the signals were constructed rather than naturally occurring, a code waiting to be understood, or perhaps simply the unfamiliar physics of an object formed under conditions alien to our experience. The distinction between an artificial signal and an unknown natural phenomenon can be frustratingly ambiguous, particularly when observing something that originated beyond our stellar neighborhood. The scientists working with this data maintained professional caution in their official communications, careful not to overstate their findings or suggest explanations that exceeded the evidence. Yet in private conversations, in late-night discussions over cooling coffee, and beneath the subtle hum of laboratory equipment, they allowed themselves to wonder. What if this pattern represented something beyond our current understanding? What if the interstellar visitor was not merely passing through but observing, recording, perhaps even communicating? As the data accumulated across days of continuous monitoring, subtle patterns emerged that defied conventional explanation. The signals appeared to contain embedded mathematics, frequency relationships that corresponded to simple integer ratios, the kind of patterns that rarely occur randomly in nature, but are often fundamental to designed systems. These relationships remained consistent despite the changing distance between Earth and the object, suggesting they were intrinsic to 3I Atlas rather than artifacts of our observation. The radio emissions contained another curious feature: brief pauses occurring at regular intervals, like spaces between words in a sentence. These silences lasted precisely 1.6618 seconds, a number immediately recognized by mathematicians as approximating the golden ratio, a mathematical constant found throughout nature and often used in human design for its aesthetic properties. Was this mathematical signature a coincidence or something more significant? Across the scientific community, specialists from different disciplines began comparing notes, seeking patterns that might cross the boundaries of their individual expertise. Astronomers examining the visual light curve noticed that the moments of maximum brightness corresponded exactly with peaks in radio emissions. Physicists modeling the object's rotation found that its axis seemed to maintain a fixed orientation toward a point in space beyond our solar system, perhaps its origin, or maybe its destination. The data presented a complex puzzle with pieces that appeared to fit together in meaningful ways. Yet the complete picture remained elusive. Like archaeologists discovering fragments of an unknown language, scientists could recognize patterns without comprehending their meaning. The rhythmic intervals, the mathematical relationships, the synchronized fluctuations across different wavelengths all suggested an organized system rather than random cosmic processes. In the quiet moments between analysis sessions, researchers found themselves contemplating philosophical questions that exceeded their scientific training. If these patterns were deliberate, what purpose did they serve? Was this a beacon, a message, a navigational system, or something whose function we couldn't begin to comprehend? The humble awareness of our limited perspective became a constant companion to the research, a reminder that we interpret the universe through the narrow lens of human experience. The signals continued their rhythmic dance, neither intensifying nor fading, maintaining their cryptic consistency as 3I Atlas continued its journey through our solar system. Each rotation brought the same pattern, each day the same tantalizing glimpse of order within cosmic noise. It was as if something was speaking in a language we could hear but not understand, a mathematical whisper from between the stars. And so the listening continued, patient and persistent, as humanity collectively held its breath, wondering what secrets this visitor from another star might eventually reveal. The efforts to understand 3I Atlas extended beyond radio observations. At the Pan-STARRS Observatory, where some of the earliest visual data had been collected, astronomers worked to construct a more detailed picture of the object's physical characteristics. Using sophisticated imaging techniques that combined multiple exposures, they began assembling a three-dimensional model based on how light reflected from the visitor's surface during its rotation. The process was painstaking, requiring precision measurements of brightness variations across different angles and lighting conditions. Each observation added another data point, another small piece of the puzzle that would eventually reveal the object's true shape. The work progressed with methodical patience, computers processing terabytes of observational data to extract meaningful patterns from the noise of distance and cosmic dust. When the preliminary model finally rendered on their screens, the room fell silent. The shape that emerged from their calculations wasn't what anyone had expected. It wasn't spherical like most asteroids, nor was it elongated like the cigar-shaped Oumuamua. Instead, the model revealed something geometric, with distinct angles and faces that seemed to reflect light in ways that natural objects rarely do. The structure appeared to have symmetry, not the rough, irregular symmetry sometimes found in nature, but precise architectural symmetry that suggested purpose rather than chance. Certain faces reflected more light than others, creating the pulsing effect that had been observed from the beginning. These reflective properties didn't match any known naturally occurring material in our solar system. A coincidence of tumbling rotation, NASA analysts noted in their official briefings, suggesting that the apparent geometric shape might be an illusion created by the object's complex rotational dynamics and our limited observational perspective. This explanation, grounded in the familiar physics of celestial mechanics, offered comfort in its ordinariness. Yet it failed to account for the consistency of the observations across different viewing angles and lighting conditions. Behind closed doors, in communications never intended for public dissemination, scientists used different language. Internal memos described structured symmetry, far too regular for natural processes, surfaces that appeared to be arranged with deliberate orientation relative to the object's rotational axis. These assessments, carefully worded to avoid speculation beyond the data, nevertheless hinted at questions too significant to ignore. Could the universe be hinting at design? Were we observing something shaped by intelligence rather than the blind forces of physics? Imagine the quiet tension in those research facilities as the implications of their findings began to register. The subtle shift in atmosphere as scientists contemplated possibilities that stretched beyond conventional explanation. In the soft blue glow of computer screens, the rotating model of 3I Atlas turned slowly, its geometric faces catching virtual light in patterns that mirrored the actual observations. The digital representation, based purely on collected data rather than theoretical assumptions, presented a challenge to our understanding of what interstellar objects should look like. The model revealed another curious feature. Certain faces of the object appeared to absorb rather than reflect specific wavelengths of light, creating distinctive spectroscopic signatures that changed as it rotated. This selective absorption suggested a surface composition unlike anything previously catalogued. Not ice, not silicate rock, not metallic compounds as we understand them. Whatever 3I Atlas was made of, it interacted with electromagnetic radiation in ways that defied easy categorization. As the model was refined with additional observations, subtle details emerged. The edges between faces appeared too precise for erosion or impact formation. The symmetry extended beyond the overall shape to include smaller structures that repeated across the surface in patterns reminiscent of engineered systems. When the modeling team applied standard geological analysis software to the data, the program repeatedly flagged the features as inconsistent with natural formation processes. Yet publicly, the scientific community maintained measured language. Press releases described 3I Atlas as an unusual interstellar object with unique reflective properties, and noted that further study is needed to understand its composition and origin. This cautious approach reflected not just scientific rigor, but also an understandable hesitation to voice conclusions that would fundamentally challenge our perception of humanity's place in the cosmos. Could the universe be hinting at design? The question lingered, unspoken in official communications but present in the minds of those working closest with the data. If this object showed signs of artificial construction, it would represent not just a scientific discovery, but a philosophical turning point for our species, evidence that we are not alone in our capacity for technological creation. The possibility remained that we were simply witnessing an object formed through natural processes we don't yet understand. The universe is vast beyond comprehension, with physical conditions varying wildly across time and space. Perhaps 3I Atlas had been shaped by stellar forces, gravitational interactions, or material properties that exist nowhere in our solar neighborhood. Perhaps what appeared as design to our pattern-seeking minds was merely the product of unfamiliar physics. Yet, as the detailed model rotated on screens around the world, as scientists examined its impossible angles and precise symmetries, a quiet recognition began to spread through the research community. Whatever 3I Atlas was, whatever distant star had sent it drifting through the void toward our small corner of the galaxy, it was carrying a message in its very form. The message might be as simple as, "The universe creates complexity in ways you haven't imagined," or as profound as, "You are not the only builders among the stars." In either case, our understanding of cosmic possibility would never be quite the same. As winter settled over the northern hemisphere, the scientific investigation of 3I Atlas continued with growing intensity and sophistication. January 2020 brought clear skies to many observatories, allowing for extended monitoring periods and more detailed data collection. The object had now crossed into the inner solar system, its trajectory carrying it between the orbits of Jupiter and Mars, making it more accessible to Earth-based observation. At the Allen Telescope Array in Northern California, a facility dedicated to the search for extraterrestrial intelligence, SETI, researchers had been monitoring 3I Atlas since its discovery. The array's multiple radio dishes worked in concert, creating a sensitive network capable of detecting even the faintest signals from deep space. For months they had recorded the now familiar rhythmic emissions without notable change, until something unexpected occurred. On January 17th, as 3I Atlas crossed a specific coordinate along the ecliptic plane, the array detected a new signal, a distinct frequency spike that stood apart from the object's usual emissions. Unlike the patterned bursts previously observed, this was a continuous tone, a single frequency maintained with remarkable precision. The signal wasn't particularly strong, just a soft hum against the background noise of space, but its sudden appearance and stability immediately captured attention. What made this emission particularly interesting was its timing and position. It occurred only when 3I Atlas passed through a very specific region of space relative to our Sun and the galactic plane, as if the object were responding to some invisible boundary or marker. The frequency itself was precisely 1420 MHz, the natural emission frequency of neutral hydrogen, often considered a logical choice for interstellar communication due to its universal presence throughout the cosmos. As the object continued along its trajectory, moving away from this specific coordinate, the signal gradually faded. Within hours, it had returned to its previous pattern of rhythmic bursts. The event might have been dismissed as an anomaly or interference, if not for a curious discovery made by a graduate student reviewing archived data from previous deep space surveys. In the quiet of a university research lab, surrounded by humming equipment and the soft glow of monitors, this young researcher found something remarkable. The exact same frequency had been detected once before, faintly, during the magnetar flare of SGR 1806-20 in December 2004. That event, one of the most powerful electromagnetic events ever recorded in our galaxy, had produced a burst of energy that briefly outshone millions of stars. Hidden within the massive data set from that observation, almost overlooked among the storm of radiation, was a brief emission at precisely the same frequency now observed from 3I Atlas. The statistical probability of this exact frequency match occurring by chance was vanishingly small. It suggested a connection between events separated by 15 years and countless light years, a pattern that transcended coincidence. When the research team compared the waveform structures between the 2004 signal and the current emission, they found matching harmonic relationships that further strengthened the improbable connection. Coincidence or connection? The question hung in the air of research facilities around the world as scientists grappled with implications that stretched beyond conventional explanation. If these signals were connected, what mechanism could possibly link a magnetar flare from deep in the galaxy with an interstellar object passing through our solar system? Was 3I Atlas responding to some cosmic event that we could barely perceive? Or was it part of a larger pattern, a network of communication spanning time and space in ways we had never imagined. In the soft light of dawn, as researchers stepped outside observatories for brief moments of rest, the stars above seemed suddenly different, not just distant suns, but potential nodes in a vast conversation of which we were only now becoming aware. The familiar constellations, mapped by human cultures for millennia, might be overlaid with another map entirely. Invisible connections between stellar events, carrier waves of information traveling between points we had always perceived as separate and silent. The frequency anomaly from 3I Atlas lasted less than 6 hours in total, yet its implications would resonate through scientific discourse for years to come. The data was analyzed, reanalyzed, subjected to every known verification technique. No instrumental error could explain it. No known natural phenomenon could account for the precise frequency match between events so distant in time and space. In the corridors of research institutions, and secure digital communications between specialists, a new possibility began to take shape. Perhaps what we were witnessing was not just an object, but a node in some vast network, a receiver and transmitter responding to signals from across the galaxy. Perhaps 3I Atlas was not merely passing through our solar system, but had been directed here, navigating the interstellar void with purpose rather than drifting at the whim of gravitational forces. This possibility that we might be observing not just an object but a process, not just matter but information exchange, shifted the theoretical framework of the investigation. Scientists began to view 3I Atlas not simply as a thing to be studied, but as an event unfolding in real time, a moment of potential contact with something beyond our understanding. As winter gave way to spring, as the object continued its journey through our solar system, the frequency anomaly was neither repeated nor explained. It remained in the data like a question without an answer, a moment of cosmic poetry that might never be fully understood. Yet its very existence expanded the boundaries of what we considered possible, opening minds to connections between cosmic events that had previously seemed unrelated. In the vast cold spaces between stars, something was happening. Some exchange of information, some network of communication that we had only just begun to perceive. Whether we would ever understand the language being spoken remained uncertain, but we could no longer doubt that a conversation was taking place. The universe, it seemed, was far more talkative than we had ever imagined. While the scientific community worked diligently to understand the nature of 3I Atlas and its unusual emissions, another pattern began to emerge, not in the data itself, but in how that data was being shared with the public. As winter turned to spring in 2020, observers noted an unusual restraint in official communications regarding the interstellar visitor. In previous cases of significant astronomical discoveries, NASA, ESA, and other major space agencies had maintained transparent communication, sharing findings and images regularly through press conferences, social media updates, and detailed reports. The discoveries of Oumuamua and Borisov had been accompanied by regular public briefings, technical papers, and a steady flow of observational data made available to the broader scientific community. With 3I Atlas, however, the pattern shifted subtly towards silence. NASA released brief statements focusing primarily on the object's trajectory and basic physical characteristics, avoiding detailed discussion of its unusual shape or emissions. The European Space Agency postponed its scheduled press conference indefinitely, citing ongoing data analysis without specifying a timeline for conclusions. Other major observatories released minimal information, often limited to confirmation of the object's position rather than insights into its nature. This public silence stood in stark contrast to the intense activity occurring behind closed doors. Telescope time at major facilities remained allocated to 3I Atlas observation at unprecedented levels. Secure servers dedicated to the project were processing terabytes of data daily. Specialists in fields ranging from astrophysics to signal analysis had been quietly reassigned from other projects to focus exclusively on the interstellar visitor. Researchers involved in the primary investigation reported subtle pressure to withhold conclusions pending verification. A standard scientific practice, certainly, but one being applied with unusual stringency in this case. Preliminary findings that would normally be shared at conferences or in preprint papers were being held back, subjected to multiple rounds of review before any public disclosure was permitted. Independent astronomers, working with smaller telescopes and publicly available data, began sharing their own observations online. These included blurred images, showing the object's unusual light reflection patterns and spectroscopic readings suggesting its anomalous composition. These independent reports, shared through academic forums and specialized social media groups, painted a picture of 3I Atlas that diverged increasingly from the restrained official narrative. Why suppress a harmless discovery? The question spread through scientific circles, spoken in hushed conversations during conference breaks, typed in encrypted messages between colleagues. If 3I Atlas were merely an unusual asteroid or comet, albeit from another star system, what would justify such cautious communication? The obvious implication, that the findings might be far from ordinary, remained unspoken in official contexts, but grew increasingly difficult to ignore. In the soft glow of computer screens, in quiet observatories where the humming of cooling systems provided the only soundtrack, researchers continued their work with a growing sense that they were participating in something historic. The data they collected, the patterns they identified, the anomalies they catalogued, all pointed toward conclusions that would challenge fundamental assumptions about humanity's place in the cosmos. Perhaps this explained the institutional caution. Throughout history, discoveries that fundamentally shifted human perspective had been met with resistance, denial, and careful management of public information. From Copernicus's heliocentric model to Darwin's theory of evolution, revelations that displaced humanity from the center of creation had required careful introduction to avoid social disruption. If 3I Atlas represented evidence of extraterrestrial technology, or even simply physical processes beyond our current understanding, the implications would extend far beyond astronomy into philosophy, religion, and the very foundations of human self-perception. The contrast between public statements and private research created an information vacuum that inevitably filled with speculation. Online forums buzzed with theories ranging from the scientific to the fantastical. Some suggested government cover-ups, alien contact. Others proposed that 3I Atlas was a natural phenomenon being misinterpreted through the lens of human pattern-seeking. The absence of comprehensive official information allowed these theories to proliferate unchecked. Meanwhile, in observatories around the world, the actual work continued, methodical, precise, and guided by the rigorous standards of scientific inquiry. Each night, as darkness fell and telescopes oriented toward the visitors' coordinates, researchers collected more data points, more evidence, more pieces of a puzzle whose complete image remained elusive. The silence surrounding their work wasn't conspiratorial but contemplative, the careful consideration of how to interpret and communicate findings that might change everything. As 3I Atlas continued its journey through the inner solar system, as spring gave way to summer, the gap between public knowledge and scientific understanding continued to widen. Those with access to the full data set were seeing a picture increasingly difficult to reconcile with conventional explanation, a picture that suggested design, purpose, and possibly communication. Those outside this circle glimpsed only fragments, hints of something extraordinary happening just beyond the veil of official disclosure. In this space between knowing and not knowing, between revelation and restraint, humanity, collectively, held its breath, waiting for confirmation of what many had already begun to suspect, that we were not alone in our capacity to shape matter with intention, not unique in our ability to send messengers between the stars. The universe had always been alive with possibility. Perhaps now we were finally ready to hear its voice. In the summer of 2020, as the world grappled with unprecedented challenges on Earth, a small community of researchers remained focused on the heavens, tracking the continuing journey of 3I Atlas through our solar system. Their work, often conducted remotely due to global circumstances, maintained the methodical pace of scientific inquiry despite the extraordinary nature of their subject. It was during this period that an anonymous document appeared on encrypted internet forums. A 16-page PDF file claiming to contain findings from a European observatory regarding the interstellar visitor. The document was professionally formatted, filled with technical language and data visualizations that suggested authentic scientific origin. Most significantly, it described observations of controlled deceleration in 3I Atlas's trajectory, movement inconsistent with the natural effects of gravity, solar radiation, or any known physical force. According to the report, the object had demonstrated subtle but measurable adjustments to its velocity that could not be explained by interaction with our solar system's gravitational field. These adjustments appeared non-random, occurring at specific points in the trajectory and resulting in deviations from predicted positions. The document included detailed mathematical models showing the expected path based on known physics compared with actual observational data, highlighting discrepancies that suggested some form of propulsion or navigational control. The report was swiftly removed from public access, but not before it had been downloaded and shared extensively across specialized networks. Screenshots circulated among astronomical communities, prompting heated debate about both the content and its mysterious source. Official scientific organizations unanimously distanced themselves from the document, with statements describing it as manufactured disinformation and warning against unverified claims from anonymous sources. Yet the technical precision of the analysis, the specific observational data cited, and the sophisticated mathematical modeling suggested authorship by someone with significant expertise and access to advanced astronomical resources. The document referenced observational data points with exact timestamps and coordinates that matched verified sightings. Its spectroscopic analysis cited frequency measurements to 9 decimal places, a level of precision typically available only to major research facilities. In the quiet rooms where specialists examined these claims, comparing them against their own observations, a troubling pattern emerged. While many dismissed the document publicly, privately some acknowledged that its core assertion, the non-gravitational movement of 3I Atlas, aligned with anomalies they had also detected but had been hesitant to report formally. The leaked document had given voice to observations that had previously been relegated to footnotes and informal discussions, considered too extraordinary for official acknowledgement without exhaustive verification. If even part of the report were true, the implications were profound. Natural objects do not decelerate independently in space. Comets may slow due to outgassing or solar pressure. Asteroids might be influenced by gravitational interactions, but the precise controlled adjustments described in the document suggested technology rather than natural physics. Something or someone was slowing 3I Atlas, guiding its passage through our solar system with apparent intention. The question of why such deceleration might occur opened new avenues of speculation. Was the object preparing for a longer stay in our solar system rather than a brief flyby? Was it adjusting its trajectory for optimal observational positioning, or was it perhaps responding to some signal or command from elsewhere, a distant controller directing its movements from across interstellar space? In research facilities connected by secure digital networks, specialists began cross-referencing their own observations with the claims in the leaked document. They found sufficient correlation to warrant concern, but not enough to constitute definitive proof. The alleged deceleration events had occurred during periods when multiple observatories had been tracking the object, creating a dataset rich enough for meaningful analysis. When these independent observations were combined and analyzed, using the mathematical model described in the document, the pattern of non-gravitational movement became more apparent. Still, official science moves with appropriate caution. Extraordinary. Claims require extraordinary evidence, and the burden of proof for controlled movement of an interstellar object would be substantial. Alternative explanations continued to be explored. Could uneven heating of the object's surface by solar radiation create sufficient pressure for the observed movements? Might interaction with the solar magnetic field influence its trajectory in ways our models hadn't accounted for? Could the object have an extremely low density or unusual composition that would make it more susceptible to forces typically considered negligible at astronomical scales? These conventional explanations were methodically tested against the observational data, each found insufficient to fully account for the movement patterns. The deceleration events were too precise, too consistently oriented, relative to the object's direction of travel, to be explained by random environmental factors. They appeared purposeful, adjustments made with specific intent rather than passive response to external forces. As summer gave way to autumn, as 3I Atlas continued its journey through our solar system, the question of its movement remained unresolved in official scientific discourse. The leaked document, despite its controversy, had permanently altered the conversation, introducing possibilities that could neither be fully embraced nor entirely dismissed. It had created a fracture in conventional thinking, a small opening through which new ideas could enter scientific consideration. In the soft light of observatories around the world, researchers continued their vigilant monitoring of the visitors' progress. They watched for further deviations, for more evidence of control rather than drift. Behind their professional composure, behind the careful language of scientific uncertainty, a new awareness had taken root, the possibility that what they were witnessing was not merely an object, but a vessel, not just matter but mission. The stars had always been silent witnesses to human history, distant and impassive in their eternal burning. Now perhaps something moved among them with purpose, reaching across the vast interstellar void not by accident but by design. If this were true, then the night sky was no longer simply a field of light and darkness, but a vast ocean upon which others might sail, carrying messages we were only beginning to learn how to read. As 3I Atlas approached the orbit of Mars in late summer 2020, anticipation grew within the astronomical community. Its position now placed it at an ideal distance for detailed observation by Earth-based telescopes, close enough for high-resolution imaging, yet still far enough to be visible for extended periods against the night sky. Observatories around the world had coordinated a continuous monitoring schedule, ensuring that as Earth rotated, telescopes in different regions would maintain uninterrupted surveillance of the interstellar visitor. Then, without warning or apparent cause, something unprecedented occurred. Beginning on September 4th, ground-based tracking systems began experiencing difficulties maintaining lock-on to the object. The sophisticated automated systems that typically followed celestial bodies with pinpoint precision suddenly struggled to locate 3I Atlas at its predicted coordinates. Initial assumptions of equipment malfunction gave way to confusion, as multiple independent observatories reported the same problem simultaneously. For nearly 6 days, tracking remained unreliable. The object would appear briefly in expected locations, only to seemingly vanish again, reappearing hours later in positions that didn't align with its calculated trajectory. The world's most advanced astronomical tracking systems, technologies, capable of following dust-sized particles in Earth orbit, somehow couldn't maintain consistent observation of an object approximately 100 meters in diameter. When reliable tracking was finally re-established on September 10th, the data revealed something extraordinary. 3I Atlas had deviated from its predicted path by several degrees. In astronomical terms, this represented a massive shift, far too significant to be explained by measurement error or computational discrepancy. The object was quite simply not where it should have been based on its previous trajectory and the known gravitational influences within our solar system. Official explanations emerged quickly, attributing the tracking difficulties and apparent position shift to software errors and calibration discrepancies across multiple systems. These explanations emphasized the challenges of tracking small, distant objects and suggested that the apparent deviation was simply a correction of previously inaccurate positioning data, rather than actual movement by the object itself. Yet private observatories and independent astronomers who had been monitoring 3I Atlas confirmed what major institutions seemed reluctant to acknowledge: the deviation was real. The object had changed course during the period of tracking difficulty, altering its trajectory in ways that defied conventional celestial mechanics. Most significantly, the new trajectory appeared to bring it into closer alignment with Earth's orbital path, potentially allowing for a nearer approach than originally calculated. In secure communications between specialists, a troubling question formed: Had something or someone adjusted its trajectory? The precision of the maneuver, occurring during a period of conveniently disrupted observation, suggested more than random influence or natural forces. It appeared deliberate, calculated, executed with timing that seemed designed to minimize detection of the actual adjustment process. The nature of the trajectory change provided additional cause for speculation. Unlike the chaotic path alterations that might result from collision with unseen objects or interaction with solar plasma, this deviation showed mathematical precision. The new course maintained a consistent relationship with both the Sun's position and Earth's orbital plane, suggesting navigational awareness rather than random deflection. Analysis of observational data from the brief periods when tracking had been maintained during the 6-day anomaly revealed another curious feature. The object's rotation had temporarily accelerated during the course of adjustment, spinning at nearly twice its normal rate, before returning to its previous rotational period once the new trajectory was established. This rotational change coincided exactly with the period of most significant positional shift, suggesting a connection between the two phenomena, perhaps indicative of some propulsion mechanism that utilized rotational momentum. In the soft light of dawn, as astronomers emerged from long nights of observation, the stars fading against the brightening sky, conversations turned to possibilities that would have seemed fantastical months earlier. What if 3I Atlas was not merely drifting through our solar system, but navigating it? What if its passage near Earth was not coincidental, but intentional? The implications were simultaneously exhilarating and unsettling, suggesting both the possibility of contact and the realization that something could approach our planetary home with apparent purpose and without our ability to prevent or even reliably track it. The official narrative remained unchanged. Software errors, calibration issues, the challenges of tracking distant objects. These explanations, grounded in familiar technological limitations, offered comfort in their ordinariness. Yet for those who had watched the data unfold in real time, who had witnessed the precision of the trajectory adjustment and its apparent orientation toward Earth, these explanations seemed increasingly inadequate. As autumn deepened, as 3 Atlas continued along its new course, the question lingered in research facilities around the world. Had something adjusted its trajectory? And if so, to what end? Was Earth itself the destination, or merely a waypoint in some longer journey? Was this approach a gesture of contact, of observation, or of something else entirely? Something beyond our current capacity to imagine? In the vast darkness between planets, the visitor continued its silent progress, carrying its mysteries forward into whatever encounter might lie ahead. Whatever its purpose, whatever intelligence might guide its movement, one thing had become increasingly clear. We were not merely observers in this event, but participants, perhaps even the intended audience for whatever message or mission 3I Atlas might represent. The night sky had always been a canvas for human imagination, a space where we projected our hopes, fears, and cosmic loneliness. Now perhaps something was looking back, adjusting its course to meet us, navigating the void with intention rather than chance. Whether this prospect brought comfort or concern depended entirely on one's perspective regarding humanity's place in the cosmic order, and whether we were ready for the responsibility of contact with something beyond ourselves. As autumn progressed and 3I Atlas continued its approach along its adjusted trajectory, a team of researchers at Kyoto University's Department of Astronomy made a discovery that would add another layer to the growing mystery. Led by Dr. Haruki Nakamura, they had been conducting a detailed analysis of the object's light curve fluctuations, the patterns of brightness variation observed as it rotated in space. Using advanced pattern recognition algorithms originally developed for analyzing pulsar emissions, the Japanese team identified something remarkable. Beneath the primary brightness fluctuations was a secondary pattern, a subtler oscillation that repeated with precise timing. This pattern alternated every 47 minutes, creating a sequence of brighter and dimmer periods that overlaid with the object's slower rotational cycle. The alternating pattern resembled binary encoding, on, off, repeating with mathematical consistency. When mapped over time, these pulses created a distinct sequence that initially appeared random but revealed surprising structure when subjected to mathematical analysis. The team discovered that the intervals between pulses corresponded to the distribution of prime numbers, those indivisible numbers that form the fundamental building blocks of mathematics. The sequence began with the simplest representation of the first few prime numbers, 2, 3, 5, 7, 11, before extending into a more complex pattern that maintained its relationship to prime number distribution while introducing variations that suggested additional layers of information. This was not simply a broadcasting of prime numbers, but a sophisticated mathematical construction that used primes as its foundation. In a paper shared through academic networks, carefully classified as theoretical rather than conclusive, Dr. Nakamura's team proposed that the pattern might represent some form of information encoding. The use of prime numbers was particularly significant, they noted, as these mathematical constants are universal, the same throughout the cosmos, regardless of who might be observing them. As Carl Sagan had once suggested in his work on potential interstellar communication, primes might well be the language of intelligence, a mathematical foundation that any technologically advanced civilization would recognize. The discovery sent ripples through the scientific community. Mathematicians who had not previously been involved in astronomical research began examining the sequence, applying various analytical techniques to extract potential meaning. They confirmed the prime number correlation and identified additional mathematical relationships within the pattern that suggested deliberate construction rather than natural phenomena. The binary nature of the signal, alternating between two distinct states, particularly evoked comparison to human digital communication systems. While the specific encoding differed from any human protocol, the fundamental approach of using discrete states to transmit information appeared conceptually similar to methods we ourselves had developed for data transmission. This parallelism raised profound questions about the universality of certain information principles, whether the binary nature of the signal represented a cosmic convergence in how intelligent systems might naturally evolve to communicate. To imagine the quiet excitement in research facilities as mathematicians and astronomers collaborated, their screens filled with waveforms and number sequences, searching for patterns within patterns. The soft hum of computers running complex algorithms provided a constant backdrop to their work, processing terabytes of observational data to extract the subtle pulses hidden within the object's emissions. With each confirmed prime sequence, with each validated mathematical relationship, the possibility of deliberate communication grew stronger. Yet questions remained about intent and meaning. If this were indeed a signal rather than a natural emission, what was it trying to convey? The mathematical nature of the pattern suggested a universal language, but the specific information encoded within that language remained elusive. Was it simply announcing its presence through recognizable mathematical constants? Was it a more complex message, whose full meaning required a key we had not yet discovered? Or was it perhaps not intended for us at all? A signal directed elsewhere that we were merely intercepting? The binary signature continued unchanged as 3I Atlas moved closer to Earth's orbital path. The consistency of the emission, regardless of the object's position relative to our planet, suggested it was an intrinsic feature rather than a directed communication attempt. It pulsed with the same mathematical precision, whether facing toward Earth or away, maintaining its cryptic rhythm as it traveled through the inner solar system. In the soft light of observatories around the world, as researchers tracked these emissions with growing fascination, a quiet shift in perspective was occurring. The mathematical nature of the signal, its prime number foundation, its binary structure, all echoed principles that human civilization had independently discovered and utilized. This parallelism suggested not just the universality of mathematics, but perhaps the universality of how intelligence might naturally develop systems to encode and transmit information. We had always wondered what form extraterrestrial communication might take, whether we would recognize it if encountered, whether mutual understanding could ever be possible across the vast gulfs of evolutionary and cultural difference. The binary signature from 3I Atlas offered a tantalizing hint. Perhaps certain principles of information theory transcend biological and cultural boundaries. Perhaps mathematics truly is a universal language spoken by any intelligence capable of technological advancement. As winter approached, as the object continued its silent journey through our solar system, its binary pulse maintained its cryptic rhythm, on, off, like a heartbeat from another world, a persistent reminder that in the vast darkness between stars, we might not be the only ones who had learned to speak in the language of numbers. As 3i Atlas continued its approach during the early months of 2021, its signals became stronger and more distinct, allowing for more detailed analysis by a growing network of observers. Amateur radio operators around the world, equipped with modest but effective receiving equipment, had joined the monitoring effort, creating a global web of independent observers sharing data through online networks. It was within this community that an extraordinary claim emerged in March 2021. A group of amateur radio enthusiasts based across several countries announced that they had successfully decoded a message embedded within the pulses emitted by the interstellar visitor. Using signal processing techniques adapted from satellite communication protocols, they claimed to have extracted a coherent pattern that, when translated through specific frequency-to-text algorithms, produced a simple but profound statement. "We are listening." The announcement spread rapidly through specialized forums and social media, creating excitement and skepticism in equal measure. The amateur group provided detailed documentation of their methodology, including the specific filtering techniques, the mathematical transformations applied to the raw signal, and the algorithmic interpretation that had yielded the alleged message. Their work appeared methodical and their documentation thorough, yet the extraordinary nature of their claim demanded extraordinary evidence. Professional scientists responded with measured caution. While acknowledging the dedication and technical skill of the amateur observers, they pointed out numerous methodological concerns. The signal processing techniques applied involved multiple subjective decisions about filtering parameters and interpretation protocols. The final translation relied on assumptions about how information might be encoded and represented, assumptions based on human communication systems rather than universal principles. Most significantly, critics noted that the alleged message, "We are listening," seemed suspiciously aligned with human expectations and linguistic patterns. The poetic, almost human nature of the phrase suggested projection rather than genuine translation, a case of finding what one hoped to discover rather than what might actually be present in the data. The phenomenon had a well-established name in science: pareidolia, the tendency of human perception to find familiar patterns in random or ambiguous stimuli. Just as people see faces in clouds or hear words in white noise, the amateur group might be detecting meaningful communication where only random signals existed. Our brains are exquisitely tuned to recognize patterns, sometimes finding them even when they aren't really there. In astronomy, this perceptual tendency has a long history. Observers have reported canals on Mars, faces on planetary surfaces, and structured signals in cosmic background radiation, all later revealed to be natural formations or random noise misinterpreted through the lens of human pattern recognition. The alleged message from 3i Atlas might simply be the latest example of this persistent perceptual bias. Yet despite these valid scientific concerns, something about the amateur group's work resonated with a wider audience. The simplicity of the alleged message, its philosophical implication, its alignment with human hopes regarding first contact, all contributed to its cultural impact regardless of its scientific validity. "We Are Listening" captured the imagination precisely because it reflected humanity's own cosmic loneliness, our own desire to be heard in the vast silence of space, in the soft glow of computer screens around the world, in quiet rooms where enthusiasts and professionals alike pondered the possibilities. A profound question emerged. What if the message was real, but we simply lacked the key to properly understand it? What if our current frameworks for signal interpretation were insufficient for truly alien communication methods? The history of deciphering unknown languages on Earth, from Egyptian hieroglyphs to Linear B, demonstrated that successful translation often required conceptual breakthroughs, shifts in perspective, that allowed previously indecipherable symbols to suddenly reveal their meaning. Perhaps 3i Atlas was indeed communicating, but in ways that transcended our current understanding of information encoding. Perhaps the binary pulses contained layers of meaning that our existing analytical tools couldn't yet access. Perhaps the amateur group had stumbled upon a partial truth, not the exact message, but a glimpse of its underlying intent. The phrase "we are listening" might not be the literal content, but it might capture the essence of what was being conveyed: attention, reception, the act of perceiving across vast distances. As spring unfolded, as 3i Atlas continued its silent journey through the inner solar system, the debate about its possible communications remained unresolved. The amateur group's claim was neither fully validated nor completely dismissed, existing in that uncertain space between proven fact and debunked fiction. Their interpretation lingered in public consciousness, a poetic possibility that spoke to something deeper than scientific certainty, the human longing for connection across the cosmic void. The alleged message, whether genuine or projected, had accomplished something significant. It had transformed 3i Atlas from a mere astronomical curiosity into a potential communicator, a carrier of meaning rather than just matter. It had shifted the conversation from what the object was to what it might be saying, from observation to dialogue. In this shift lay a profound change in humanity's relationship with the cosmos, a tentative step from passive witnesses to active participants in a conversation spanning interstellar space. Whether the message was real remained uncertain. But the idea that lingered, that somewhere in the darkness between stars something might be listening, had already changed us, opening minds to possibilities previously confined to fiction. And perhaps that opening, that expansion of what we considered possible, was itself a form of contact, the first subtle effect of an encounter with something beyond ourselves. As spring blossomed across the Northern Hemisphere in 2021, the scientific investigation of 3i Atlas had evolved into a global, multidisciplinary effort involving thousands of researchers across dozens of countries. What had begun as a purely astronomical observation had expanded to include specialists in mathematics, information theory, linguistics, and even anthropology, all attempting to understand not just what the object was, but what it might represent and potentially communicate. During this period, rumors began to circulate about a closed-door summit being organized between international space agencies. Initially dismissed as speculation, these rumors gained credibility when investigative journalists uncovered travel records showing an unusual convergence of high-ranking officials from NASA, ESA, Roscosmos, CNSA, and other major space programs all arriving in Geneva, Switzerland during the same week in late April. The official explanation, when it finally came, described the gathering as a scheduled meeting to discuss data harmonization, protocols and international cooperation frameworks for deep space monitoring, routine administrative coordination that happened to coincide with the ongoing observation of 3 Atlas. This explanation, delivered through carefully worded press releases, emphasized the technical and bureaucratic nature of the discussions. Yet leaked attendee lists suggested a different focus entirely. Among those present were not just administrative officials and astronomers, but also specialists whose expertise seemed peculiarly aligned with the challenges of potential communication. These included Dr. Eleanor Hirsch, a linguist whose pioneering work in computational language analysis had revolutionized approaches to unknown symbolic systems, General Victor Kowalski, a senior military liaison with background in first contact protocols, originally developed for hypothetical scenarios, and Dr. Wei Zhang, whose research in cryptographic AI specifically focused on detecting patterns in seemingly random data structures. The aorist presence of such specialists at what was officially described as a routine administrative meeting raised questions about the true agenda. Why would experts in decoding unknown languages, military contingency planning, and advanced pattern recognition be necessary for discussing standardized data formats and cooperative frameworks? The composition of the attendees suggested a far more significant purpose, debating how humanity should respond if 3i Atlas were indeed attempting communication. Insiders with knowledge of the summit, speaking anonymously to protect their positions, described intense discussions focused on a profound question: whether humanity should attempt a reply to the signals being emitted by the interstellar visitor. This question, seemingly simple, opened into complex ethical, philosophical, and security considerations that divided the participants along multiple lines. Some argued passionately for immediate response, suggesting that the opportunity for contact with another intelligence might be fleeting, and that hesitation could result in a missed historic opportunity. Others counseled extreme caution, noting that broadcasting our presence and capabilities to an unknown entity carried potential risks that couldn't be fully assessed. Between these positions lay numerous nuanced perspectives, each balancing scientific curiosity against prudential concerns, the advancement of knowledge against uncertainty. A fundamental question emerged during these deliberations. Who decides when contact becomes communication? What authority, scientific, governmental, or international, had the right to speak on behalf of humanity to whatever intelligence might lie behind 3i Atlas's signals? The existing frameworks for space exploration had never anticipated this specific scenario, leaving a vacuum of established protocol for such a momentous decision. In the elegant conference rooms of Geneva, as spring rain tapped against tall windows and the lake glimmered beyond, representatives from nations often at odds politically found themselves united by a challenge transcending geopolitical boundaries. Whatever 3i Atlas represented, whether a technological artifact or simply an unusual natural phenomenon, it had accomplished something remarkable. It had forced human institutions to confront their limitations in the face of cosmic questions. The discussions continued for 5 days, longer than officially acknowledged. No comprehensive agreement was reached regarding response protocols, but certain principles were established. Any potential communication would require broad international consensus rather than unilateral action. Scientific verification standards would be extraordinarily rigorous before any signal would be officially recognized as non-natural in origin. Contingency planning would proceed along multiple tracks, preparing for various scenarios without committing to specific responses. Most significantly, a decision was made regarding public disclosure. Information would be shared progressively as confidence in its interpretation increased, avoiding both premature announcements that might later prove false and extended secrecy that could undermine public trust. This middle path reflected the delicate balance between scientific responsibility and public right to knowledge about potentially transformative discoveries. As the summit concluded, as participants returned to their respective countries and institutions, they carried with them a shared awareness that transcended their professional roles. They had glimpsed, perhaps for the first time, the true scale of the question before them, not simply whether another intelligence existed, but how humanity itself would be transformed by the certainty of not being alone. In the soft evening light of Geneva, as the last participants departed, the lake reflected a sky transitioning from blue to indigo, stars becoming visible one by one as darkness deepened. Somewhere above, beyond human sight but not beyond human awareness, Atlas continued its silent journey through our solar system, carrying its mysteries, its possibilities, its unanswered questions about who decides when observation becomes dialogue, when listening becomes speaking, when isolation becomes connection. The summit in Geneva had not provided final answers, but it had accomplished something perhaps more significant. It had acknowledged that the questions themselves were valid, that the possibility of contact required serious consideration rather than dismissal. In this acknowledgement lay a subtle but profound shift in humanity's relationship with the cosmos, a tentative opening to possibilities previously confined to speculation and fiction. Whether anyone would ultimately respond to 3i Atlas remained undetermined. But the careful, thoughtful consideration of the possibility had already changed us, preparing minds and institutions for a future in which Earth might not be the only world with a voice in the vast conversation of the stars. As 3i Atlas continued its journey through the inner solar system during the summer of 2022, a private research organization based in Zurich made an unprecedented decision. The Quantum Information Systems Foundation, a non-governmental research group funded by technology entrepreneurs and academic institutions, announced that they would apply advanced neural network technology to the accumulated observational data from the Interstellar visitor. The project represented a significant departure from traditional analytical approaches. Rather than human researchers examining the data for patterns based on existing theoretical frameworks, the Foundation would utilize a specialized neural network architecture designed to detect patterns without preconceptions about what form those patterns might take. This approach, they argued, might reveal structures and relationships invisible to human perception or theoretical models. The neural network they employed was not a standard machine learning system, but a quantum-enhanced architecture, incorporating elements of both classical and quantum computing. This hybrid approach allowed for analysis across multiple probability states simultaneously, potentially revealing correlations that would remain hidden to conventional algorithms. The system was particularly adept at identifying patterns across different types of data, linking visual observations with radio emissions, spectroscopic readings with trajectory calculations, creating a holistic analytical framework. For weeks, the system processed terabytes of observational data, collected from dozens of sources around the world. It ingested everything from radio telescope readings to spectrographic analyses, from high-resolution imagery to mathematical models of the object's movement. As it processed this information, it continuously refined its internal representations, developing increasingly sophisticated models of the patterns it detected. After nearly 3 weeks of continuous operation, the AI system produced something remarkable: a predictive model that could anticipate the object's emissions, rotational patterns, and even subtle trajectory adjustments before they occurred. The model demonstrated accuracy rates exceeding 99.7% when tested against new observational data not included in its training set. It could predict, with extraordinary precision, when specific emission patterns would occur, how the object's brightness would fluctuate, and where exactly it would be positioned at any given moment. This predictive capacity suggested that the AI had identified underlying patterns governing 3I Atlas's behavior, patterns too complex for human analysts to fully perceive, but nonetheless real and consistent. Some researchers saw this as validation of theories, suggesting intelligent design behind the object's movements and emissions. If an artificial intelligence could learn to predict its behavior with such accuracy, they argued, this implied an underlying logic or programming rather than random natural processes. Others maintained scientific caution, noting that neural networks can find patterns in any dataset, including purely natural phenomena. The AI's ability to predict 3I Atlas's behavior might simply reflect its capacity to model complex physical systems rather than indicate artificial origin for the object itself. After all, similar neural networks had successfully modeled weather patterns, stellar life cycles, and other entirely natural processes with impressive accuracy. What transformed the debate was what happened next. As the research team continued to work with the AI system, allowing it to refine its models through additional observational data, they began to notice something unexpected. The system started generating what appeared to be response patterns, sequences of emissions that would theoretically be recognized by 3I Atlas based on the patterns it had been producing. In essence, the AI wasn't just modeling the object's behavior. It appeared to be learning what might constitute a recognizable reply within the same symbolic framework. It had moved from observation to potential communication, developing what might be described as a rudimentary understanding of the underlying language embedded in the object's emissions. This development created immediate concern among the research team. They had intended to create an analytical tool, not an independent communicator. The possibility that their AI might be developing the capacity to engage with whatever intelligence might lie behind 3I Atlas raised profound questions about control, authorization, and potential consequences. Who would be responsible if an artificially intelligent system initiated contact with an extraterrestrial intelligence without human oversight or approval? When questioned about these developments, about the apparent communication protocols their AI had derived from 3I Atlas's emissions, the research team made a decision that surprised outside observers. They quietly shut down the project, citing unexpected behaviors requiring further evaluation. All public announcements ceased, all publications were suspended, and the Foundation declined further comment on their findings. This abrupt termination fueled speculation. Had the AI discovered something that alarmed its creators? Had it begun communication attempts without authorization? Had it revealed something about 3i Atlas that proved too sensitive for public disclosure? In the absence of official information, theories multiplied across scientific forums and public discourse alike. What remained undisclosed to the broader public was a final observation made by the research team before shutting down their system. In its last active hours, the AI had generated a message in response to the patterns it had detected from 3i Atlas. This message, encoded in the same mathematical structure it had identified in the object's emissions, translated roughly to a simple acknowledgement of presence. "We see you." The team never transmitted this message. The system was disconnected before any such transmission could occur. But the very fact that an artificial intelligence had independently derived what appeared to be a compatible communication protocol from observing 3i Atlas raised profound questions about the nature of the information embedded in the object's emissions. If an AI could learn to speak this language through observation alone, what did that suggest about its fundamental structure? In the quiet aftermath of the project's termination, as equipment was powered down and data securely archived, the research team found themselves contemplating possibilities beyond their original scientific objectives. Perhaps the most significant discovery wasn't about 3i Atlas at all, but about the nature of information itself, about patterns so fundamental to reality that they might transcend the boundaries between biological and artificial intelligence. Between Earth-evolved and alien minds, the AI experiment, though brief and ultimately suspended, had provided a tantalizing glimpse of possibility. That communication across the vast gulfs of evolutionary difference might indeed be achievable, not through shared biology or culture, but through the underlying mathematical structures that appear to govern information exchange throughout the cosmos. Whether this possibility would ever be tested remained uncertain, but the theoretical foundation had been established, waiting for humanity to decide whether to take the next step toward conversation with the stars. As summer faded into autumn in 2022, astronomers tracking 3i Atlas noticed something unexpected: a significant change in the object's luminosity. Over the course of approximately 72 hours, its brightness increased dramatically, nearly doubling in intensity across all observable wavelengths. This shift was not gradual, but occurred in distinct stages, suggesting a structured process rather than a random natural event. Telescopes around the world quickly focused on this new development, capturing high-resolution imagery and spectroscopic data to understand what might be causing such a dramatic change. The increased brightness wasn't limited to visible light, but extended across the electromagnetic spectrum, including infrared, ultraviolet, and even mild radio frequency enhancement. Scientific analysis of this phenomenon yielded no clear natural explanation. The spectral signatures showed no evidence of outgassing, which might occur if the object were a comet suddenly exposed to increased solar radiation. There were no signs of collision or fragmentation that might expose reflective interior surfaces. The object's trajectory remained consistent, ruling out approach to a reflective body or entry into a region of space with increased particulate matter that might scatter light. In fact, detailed spectroscopic analysis revealed something particularly unusual. The increased luminosity appeared to be coming from the object itself rather than reflected solar radiation. The emission spectrum showed characteristics more consistent with generated light than reflected light, a distinction with profound implications. If 3i Atlas were generating its own illumination rather than merely reflecting sunlight, this would suggest energy production capabilities far beyond what natural space objects typically possess. As observatories worldwide collected data on this luminosity shift, a pattern emerged in how the brightness had increased. It hadn't simply amplified uniformly, but had changed in a structured sequence. First one section of the object brightening, then another, in what appeared to be a coordinated process extending over 3 days. This sequential pattern suggested something more complex than a passive physical change. It resembled an activation sequence, a deliberate process of energizing different systems or components. One astronomer, Dr. Sarah Chen of the Keck Observatory, described the phenomenon in terms that would be widely quoted Despite their departure from typically cautious scientific language, it's behaving like a beacon, blinking to the void. The light signature resembles nothing so much as a lighthouse activating its lamp, creating a signal visible across vast distances of space. The comparison to a beacon or lighthouse raised an inevitable question. If 3i Atlas were indeed signaling, to whom was it speaking? Was Earth itself the intended recipient, or was the object communicating with something farther away, perhaps beyond our current observational capacity? The timing of the luminosity increase, occurring as the object reached its closest approach to Earth's orbital path, suggested possible relevance to our planet, yet the directional characteristics of the emissions indicated a focus toward a specific region of space beyond our solar system. Analysis of the emission patterns revealed another curious feature. They appeared to be directionally focused rather than uniformly radiated. The object was not simply glowing brighter, but was projecting increased luminosity along specific vectors, creating what amounted to a narrow beam transmission into space. This directionality further strengthened the impression of purposeful signaling rather than a natural phenomenon. Some proposed that what they were witnessing was the deployment of a reflective structure, perhaps a solar sail or energy collection system that had previously been folded or inactive. The geometric precision of the luminosity patterns, combined with their sequential activation, aligned with theoretical models for how such structures might unfold and orient themselves to capture or redirect radiation. Others suggested more exotic possibilities. Perhaps 3i Atlas was activating some form of communication array, preparing for more direct transmission after months of passive observation. Perhaps it was aligning energy systems for the next phase of its journey, whatever that might be. Perhaps it was simply responding to crossing some predetermined distance threshold from our planet or sun, triggering automated systems designed to activate at specific coordinates. In research facilities around the world, screens displayed the increasingly bright signature of the interstellar visitor. Conversations shifted from observation to anticipation. Something was happening. Some process was unfolding that transcended the passive drift of natural objects through space. Whether technological activation, communication attempt, or an entirely natural phenomenon, we simply lacked the framework to understand. 3i Atlas had entered a new phase in its interaction with our solar system. The increased brightness made the object visible to smaller telescopes, expanding the network of observers beyond professional astronomers to include amateur stargazers worldwide. Reports began to accumulate from across the globe. The visitor could now be seen with modest equipment, appearing as an unusually bright point of light moving steadily against the fixed background of stars. This broader visibility transformed 3i Atlas from a specialist scientific interest to a public phenomenon, something ordinary people could observe directly, connecting them personally to this extraordinary cosmic event.